Hi, my name is Tori Morgan. I am a postdoctoral research associate at the University of Illinois, Urbana-Champaign, working with the Quantitative Sustainable Design for Sanitation and Resource Recovery Systems, also known as QSDsan group. Today, we will cover two important topics of SAN units, including understanding what a SAN unit, SAN units, and unit is, and using existing SAN unit subclasses. So let's get started with tutorial 4, SanUnit Basic. To get started, go to the QSDsan, read the docs, and under tutorials, we're going to go to SanUnit Basic. The SanUnit class is used to model the design and operation of a unit through default or user-implemented algorithms. When running the simulation, it will generate the influent, effluent mass, and energy flows, along with the construction and operation inventories. It is one of the most extensible classes in QSDsan and most directly relevant to new technologies. In this tutorial, our main focus is on understanding how to use existing SanUnit classes. In the next tutorial, we will cover creation of new SanUnit classes and SanUnit Advanced. If you haven't already, open up your Jupyter notebook so that we can run this tutorial together. If you need help on how to do this, please reference the first tutorial on helpful basics. Once we have our Jupyter notebook open, we can then import QSDsan. Import QSDsan as, and remember you can import as whatever you'd like. I'm going to stick with QS. And then we can see what version of QSDsan we are working with by printing this line of code that will print our version. So at the time of this video, I am working with version 3.6. So now let's look at the difference between SanUnit and SanUnits within our code. So first thing we can do is qs.sanUnit and print that. So the output means that the SanUnit is a class in the _SanUnit module. The file _sanunit.py is within the QSDsan folder. The script file contains the codes used to develop the class SanUnit. Adding equipment to a unit operation with equipment or equipments and process and/or processes for dynamic simulation will be discussed in future tutorials. So let's try that same code, but now we're going to look at SanUnits. From the output, we can see that SanUnits is a folder that contains unit operations such as subclasses already developed using QSDsan. You can access these subclasses with the following code. So look at this note right here. We can copy qs.sanunits, and then the SanUnit name. So this is just a template for now. So you need to type in an actual SanUnit name. So we can type in pit latrine, or we could type in toilet and see if it's a SanUnit. So we see that toilet is a SanUnit within the _toilet. So now let's see if, what are all of the units that we could use within here. So what we can do is we can print the directory of all the SanUnits for the existing SanUnits. And so now you can see we have some reactors, we have a lagoon, we have a pump, everything from a urine diverting dry toilet right here. So now we know the difference between a SanUnit and SanUnits, but let's look at SanUnit versus a unit. So let's learn at how to use the class by doing the question mark, qs.S for SanUnit. So SanUnit is a subclass within the unit class in BioSteam. This means that SanUnit inherits the attributes of the unit class while having some new features, such as dynamic simulation, and it supports comprehensive LCA, or life cycle assessment. In QSDsan, if a class inherited from a BioSteam class, the class level document will only display the new features, but the documentation of the attributes from the superclass is still accessible. So let's type in the next line of code here. And you can see that's inherited from the BioSteam class. So we can see that underscore or double underscore basis double underscore attribute is a tuple because one class can have multiple superclasses. But in this example, SanUnit only has one superclass, and that's unit. But we can do another subclass, such as, let's say, toilet. So we can do so here, if we try toilet, we can see that there's two superclasses, SanUnit and decay. Now we can learn how to use existing SanUnit subclasses, or in Python terms, creating instances of a SanUnit subclass. We first need to tell QSDsan what components we are looking for. So we can run this line of code right here. Now we have initialized our components for simulation. Let's work with the mixer component as an example of simulation. There are three methods we can use to make random influence. First, let's add an influent by directly providing the flow rates of select components. So here's method 1 right here, where we're directly providing the flow rates for ens1. Next, we can add an influent by using copy and adjust the flow rates later. So we can use the copy to create N2. Finally, we can try an example using default models. So here's the last line of code for ens3. Looks like it ran successfully. So finally, we can initialize the instant and pass the influence through the ens argument. We can use this code right here by making a shorthand for what our SanUnits are. And then just like any other class, we can use our show method to see if our ens were computed successfully. So let's see. M1 is not defined. Oh, yes, I forgot one line of code right here. So as it says here, and I missed it, this is the actual line used to initialize the instance. So we'd have to do this first. And then let's try M1 show again. Let's see, we have WS1, which is our first N, WS2, WS3. But then for WS4, we have a flow rate of 0. So let's create our effluent by simulating the unit. So simulate. And now that we've simulated it, we should be able to see our effluent. We have S1 and then here's S4. Yep, looks like it's finally we have an effluent. Now we see our effluent is being simulated. We can use mix from to generate effluent of the mixer. So call it WS4 for waste stream 4. And we can check to see if the flow rate of WS4 or effluent is the same as the effluent of mixer 1. So we have an array of trues, which means that our flow rate of WS4 is the same as our effluent of the mixer MS1. If we want, we can visualize this through a diagram to see our influence and our effluents. So ins and outs is to set and retrieve the influence and effluence of a unit. So here's our diagram to visualize what we're talking about. If your code does not output the diagram, you probably haven't installed the package GraphViz yet. For more information, check QSDsan's documentation on the issue by clicking this link right here. So we just worked with the mixer SanUnit. We can try another example and see how we can retrieve the design and cost. So let's reset the components here since we introduced the BioSteam environment. So we copy, let's get the show to. So here it shows our mixed tank SanUnit. And let's evaluate what we just did. By setting outs equals M2 out, we set the ID of the effluent to M2 out. We can make a stream ahead of time and set the effluent to that stream, such as outs equals QS dot waste stream into out, as you see here. If the unit has multiple effluents, then you'll want to use an iterable. This is applicable to ends as well. You'll see warning about streams being undocked from the previous unit and docked at the new unit. This is because we set the ends of M2 to be the same as the ends of M1. One stream can only go to one unit, and these streams will be taken away from M1 and connect to M2. So let's look at the design of our mixed tank, also known as M2. So we must first simulate it. And then we can see what the results of our mixed tank is. So here it gives the units by the power, design, purchase cost, and it shows the purchase cost is the tanks, the total purchase cost, and it's the same as the purchase cost because we only have one purchase cost. If we had multiple, it would sum all those together. The utility cost, and then any additional operation cost. So if there was labor or replacement and things like that. If there's a utility usage, it'll be shown in the result as well. So we can look at this example right here. And see here, it shows the utility usage of the SanUnit. So we could have seen it in the results up here, like I mentioned, for the mixed tank, But also, if we wanted to look at an individual cost, we can print that out as well. So here we'll show the purchase cost. So remember, this is the sum, the total purchase cost or total capital cost. So here's the total purchase cost. And then we can look at the individual costs that make up the purchase cost. So here it happens to be the same. And that's because, as I mentioned earlier, the only purchase cost is the tank. And so the purchase cost, or the sum of all the purchase costs, will be the same. If we looked at a different SanUnit, like a pit latrine, that might have different purchase costs associated with it that you could see when you print this script right here. Or if you look at multiple SanUnits, you could see the purchase costs. So one last thing to note is that some units may require specific components or a certain number of influence, such as these following errors that you see here. For those units, the best way is to look at the documentation and examples for those SanUnits. That concludes the end of this tutorial on SanUnit basics. To summarize, a SanUnit is a class used to model the design and operation of a unit through default or user-implemented algorithms. SanUnits is a folder that contains the unit operations, such as subclasses of SanUnit, that have already been developed using QSDsan. SanUnit is a subclass within the unit class in BioSteam. Thus, SanUnit will inherit the attributes of the unit class while having some new features, such as dynamic simulation and comprehensive lifecycle assessment. We can use existing SanUnit subclasses or create instances of a SanUnit subclass by initialization and simulation. There are 3 methods for creating or initializing influence, including first, directly providing the flow rates of select components, or using copy and adjusting flow rates, or using default models. Once your units are initialized, the units have to be simulated to capture the correct effluence. Then we can retrieve design and cost information of the SanUnit. Stay tuned for an advanced tutorial on SanUnit and check out the documentation on GitHub. Thanks for watching.